Welcome to this edition of DevTalk with Rich and Vin. I am Rich Nass. I am the Executive Vice President of Open Systems Media. I lead the team for embedded computing design. And with me on my other half is Vin D'Agostino. How you doing, Vin?
Good, Rich. How are you?
Good. So I had that long title. What do we use for a title for you?
Oh, I don't know. Vaudevillian plate spinner. I was thinking I would change my business card to because I'm always trying to keep everything up in the air moving. But
Okay,
engineer
so
and
what percentage of
technologist.
our audience knows what vaudeville is?
Oh, probably a very small percentage, but a lot of them will also Google it. Actually, most of them will chat GPT it, which will be 1,000 times the amount of energy for the same information.
Ask
So
your dad.
yeah, ask your dad. Exactly.
Anyway.
Oh, God.
So interesting subject this week, and I know I didn't prepare you, so we'll see how this goes. I was talking to one of the vendors the other day about topics for white papers, and we were going through all the list of topics, things we should do, and AI is very much in vogue, and we always talk about security and 5G and stuff like that. And one of the things that we talked about was we make a lot of assumptions when we deal with our audience, and we assume that they know stuff, and it sort of shed a light for me when I look at things that are the most popular content on embedded computing design. Most of the time it's things that are 101 type stuff, the basics of X. And I always wondered whether it's somebody who's not a traditional embedded developer who's reading that stuff, or is it a traditional embedded developer who just wants some background on stuff. So I know you deal with these people all the time. Or should we not be making assumptions that people know as much as we think they know? Or is it that they're just looking for, like, they want to get their ideas validated?
You know, it's a great question, and it's actually something that I work with all the time. You know that I'm teaching at university embedded systems, an intro to embedded systems, but I also do a lot of speaking, and I do a lot of e-learning stuff for my clients that are customer facing. And you can never assume, once people are in the wild, you can never assume what they bring to your seminar, your conference, your little teaching. What information they're bringing with it. When you are in the school system, there is an assumed amount of knowledge at the beginning of each scholastic year. And so everyone assumes this base knowledge and you can build on it. But when you are assembling a group of people that have different backgrounds, they're all going to know different things. And, you know, you and I grew up through the MCU, MPU development age. And so you're a little younger than I am, but I still remember at the beginning having to hand assemble things on a piece of paper and then look up the opcodes and put the hex codes down and then type them in by hand, because it was that early on in its infancy, right? And now, of course, we have very rich tools to help us do all of that, and we're developing in high-level languages. But someone who grew up through
that you just talked about is so important, that to really understand, and I'm doing air quotes if you're on the podcast version, to understand what is happening in the background.
It's, yeah, you know, I in my first class every semester, I say the same few things, which is that firmware is different from software development for two reasons. One, you need to really understand the hardware underneath it, where if you're writing software to a desktop or a server, there's an API layer, and all that stuff underneath it is handled for you. But also you have limited resources. I joke that software engineers think they have unlimited resources, and firmware engineers are much smarter than that, right? We know that the code has to fit in a certain amount of space. We know that the data needs to fit in a certain amount of space. We know that there's a concept of time, because a lot of the things that we're doing are real time. And if, you know, a query comes back a half a second later, nothing breaks. But if you commutate a motor a few milliseconds late, you lose efficiency, you could blow up transistors, there's lots of things. So the whole concept of these things that are different in firmware engineering than in software engineering is so important. And I have a lot of people who come to my classes at Santa Clara, and even the summer workshops I do at Stevens, who have a software background are trying to understand the hardware more, or have a hardware background and try to understand the software part of it more. So
So
it
bring this back
really
up
is.
to where we started, though, because I think you're actually not making my argument of talking about people who are from a different discipline who are coming in and looking for this basic stuff rather than the people who are already planted there.
Well, on one level, I would tell you that the hardware and the software are two different disciplines that meet at the firmware level to some extent. But I've had people that were mechatronics or mechanical engineering people in class that need to learn both. And, I was having a discussion just the other day. I was with someone who does branding for a living, and we were talking about some stuff. And I said, when you go to engineering school, people think you learn engineering. Now you got me doing the air quotes. But engineering isn't a thing. When you go to engineering school, you learn a set of problem solving skills, you learn a language, and you learn some troubleshooting skills in your area of expertise to notice and build intuition when something is not right. And so to move from one engineering discipline to another, in theory, you need some understanding of the system so you can build some troubleshooting intuition, and you need to learn the new language. And because the problem solving skills are roughly the same. The problems are different, but the way you approach getting data, sorting through the data, figuring out what needs to happen, what your expectations are, and why what's happening is falling short. Those are all sort of general engineering skills that will translate from mechanical to electrical to software. And so when you are building stuff, which, you guys are putting stuff on the webcast, so it's by definition asynchronous, right? The instructor is not in the room. I say this all the time, even the least inspired lecturer can tell in the room who's tuned in and who's tuned out and who's getting it and who's not getting it, and can, if they want, alter what or how they present to try to bring everyone together. It's really hard to do remotely. It's impossible to do asynchronously because you're simply not in even a virtual room with them. And so you need to walk a line between not boring the people who have a lot of background, because by the time you get to the new stuff, they've tuned out. Excuse me, they've tuned out.
But the stuff we're doing, obviously they have the option of not. They have the option of not looking at what we're posting. If they don't like the article, then they just move on. It isn't like we're forcing them to read this stuff, but they're telling us by their actions that they really do want to see this stuff in big numbers. So going back to the original question, are we making the wrong assumption that people know more than they know?
The answer, I think, is yes. You shouldn't assume that they know all of the background. I mean, we talk all the time in good writing that you don't use an acronym without defining it the first time, and then you can use it, right? In some spaces, people know the acronyms with no trouble. In some spaces, they have no idea. I was taking a digital marketing thing a couple of years ago, and they were talking about avatars, and I'm like, do I have to watch the movie again? Like what am I supposed to know here? What's an avatar in your space? And asking a lot of people and learning a lot of things. You're in the web space, so you know about click-throughs and you know about all of that stuff. I knew none of that stuff, and they were using all of the 3-letter acronyms for all of them, and I had to sit down and learn all of them before I can even make sense of the conversation. And there was a room where there was an assumption that everyone in the room knew what was going on, and there was at least one.
But to be fair, you were going from a different industry into that industry, and what we're referring to now is people who are in the industry, and we're assuming that they know or don't know.
Well, yeah, but to some extent, this is all interconnected, right? When I counsel students, I tell them never have lunch with people in your department, have lunch with people outside of the department, because you as an engineer are more valuable to your organization if you understand the implications of the decisions you make as an engineer on the rest of the organization. You make decisions A or B all the time, and A may make it easier to build in manufacturing. B may make it easier to support in the field. And if you don't understand that, to you, it's an arbitrary decision. So I would argue that none of this stuff really exists for an engineer in isolation. And so I would say that there is some sort of remedial work that you need to do when you do it. But I mean, let's say you were talking about AI, right? And you were going to do a whole module, embedded AI or tiny machine learning 101. You would still have to start with some amount of basics for someone who's coming to AI for small systems
Yeah, but
with an AI
I mean,
background.
I'm talking about the things that we assume that they know. Basics of resistors. When we post this stuff, we get a lot of people who read these articles, and I I would have assumed that they know this stuff. I'm not talking about AI and the latest technology. I'm talking about the things that have been around for a long time that they're still telling us that they need to learn.
Uh, Yeah, for a lot of people, they come to their engineering not having had the basics because they came out of a need and they just jumped in and they learned what they needed to learn at the time. And a lot of the basics aren't there. I was talking to a young guy about a year ago, and he's like, I don't have to go to university because anything I want to learn, I can learn on YouTube. And I said, yes, that's true. Although if you were a YouTube brain surgeon, I wouldn't want you working on me. But what you get out of a university program in theory is a curated delivery of information in the order that lets you build the knowledge to maximize your effectiveness. You want to learn about something, you Google it, you go and learn one thing on YouTube, but you don't have all the background that helps you build the intuition in this thing that you just learned, right? And that's really what the background does. Background and experience helps you draw conclusions about things that you wouldn't have just by having the data. I'm reading an interesting article. Let me start again. I'm reading an interesting book right now that someone gave me the other day. In fact, you might remember Dana Davis from some of the battery conferences.
Mm-hmm.
We had dinner. We had dinner with her and her husband, and her son sent me a book to read. And it's about genius and what defines genius. And there's a great line at the beginning of the book that says, talented people can hit the target in the right place every time. Geniuses hit targets that nobody else can see, right? Yep. And that's a great line because someone who doesn't have the background can hit a target when they need to now and then, but without the background, they don't even have the talent to hit the target in the same spot every time. And that comes from having the background information and having built intuition in your space. I would not assume that people know any of this stuff, and I would put more and more basic content out there. I'm actually, you and I have talked about this. I'm looking at taking my university class and making it available online as a boot camp because so many people ask me about it. And I've had so many students call me afterwards because they all have my cell number because I'm that kind of professor that annoys all the other professors, and said, I use the stuff that you taught in class every day at work. And I had one student call me and say, I just left a job interview. They asked me 11 technical questions. You covered 9 of them in your class. And they were so surprised that I knew any of them because they said most new graduates don't know any of these things. And
they got that from reading our content on embedded computing design.
I'm sure they did. It wasn't my class. I, always talk about your content. And so they all go and
I do not give out my cell phone number for what it's worth.
So, but there's a thirst, and it's interesting when you talk about, we were joking earlier about, our audience not knowing what vaudeville was. There is an interest in young graduates now that you and I never, I think, thought about when we graduated. I've had so many students ask me, how do I remain relevant for my career? How do I not become obsolete? When you and I graduated, most things are pretty stable. The equations for electrical engineering were the same for years. The equations for mechanical engineering were the same for years. The chemical reactions in chemical engineering were the same for years. And in comes software and all of the changes, and it's the youngest engineering discipline, and it's changing so quickly. And there is a realization by these students that, even if they're not software engineers, there's an element of what's going on in their working life that's going to be rapidly changing. And how do they remain relevant? I never asked that question as a graduating engineer. I just said, I'm an engineer. I'll be designing circuits the rest of my life, or running my own business, or whatever it was. But people are concerned about it, and having these basics available by you and the website I think are really important. And
okay. I think we should wrap here, and I think we've answered the question. We do need to keep going back to basics.
100%,
The
100%.
audience is telling us that, so we should probably listen to the audience.
Cool.
Thank you, Ben. This was a very educational one. I mean, not just for me, but hopefully for the audience as well. So it's okay to not know.
It's okay to not know, and it's okay to say you don't know, which is even more important, I think.
Yep. All right. Until
All
next
right.
time.
Yep.
Take care.
Bye-bye.